Hello student, I am Mrs. Harsha Zope from Praveen Patel Polytechnic, Bhayandar. Today we are going to start our chapter 3, that is software modeling and designing. Learning outcomes of these videos are, after watching this video, you will be able to know about translating requirement model into designing model, data modeling, analysis, modeling. First start with translating requirement model into design model. Software design is at the core of software engineering and it is applied irrespective of any process model. After analyzing and modeling the requirements, software design is done. It serves as the basis for code generation and testing. Software designing is a process of translating analysis model into design model. Analysis model is manifest by scenario-based, class-based, flow-oriented and behavioral elements. Architectural design defines the relationship between major structural elements of the software. The architectural style and design pattern can be used to achieve the requirement defined for the system. The interface design describes how software communicates with system. These systems are interacting with each other as well as with the humans who operate them. Thus, interface design represents the flow of information and specific type of behavior. The usage scenario and behavioral model of analysis modeling provide the information needed by the interface design. The component level design transforms structural element of software architecture into procedural description of software module. The information used by the component design is obtained from class-based model, flow-based model, and behavioral model. Software design is important to access the quality of software because design is the only way that we can accurately translate the user requirements into the finished software products. Without design, understandable system may get developed. Then next is the data modeling. Data modeling, what it is basically a step in the analysis modeling. In data modeling, the data objects that are considered. The data domain is focused. First, we will see the term that are related with data modeling. First is the data and then objects, attributes and relationship. First, what is a data object? Data object, it is a set of attributes that are also called as data items that will be manipulated within the software, that will be manipulated within the system. Each instance of data object can be identified with the help of unique identifier. For example, a student can be identified by his roll number. The system cannot perform without accessing the instance of object. Each data object is described by the attributes which themselves are data items. Then what is data object? Data object is a collection of attributes that act as an aspect, characteristics, quality or descriptor of the object. For example, vehicle is a data object and the attributes for them is make, model, color, owner, price. Then what are the attributes? Attributes that define the properties of data objects. Typically, there are three types of attributes: naming attributes, descriptive attributes, and referential attributes. Naming attributes are the attributes that are used to name an instance of data object. For example, in a vehicle, data object, make and model are naming attributes. Secondly, descriptive objects, attributes. These are the attributes that are used to describe the characteristics or features of the data object. For example, in a vehicle data object, color is a descriptive attribute. Third is referential attributes. These are the attributes that are used in making reference to another instance in another table. For example, in a vehicle data object, owner is a referential attribute. The next is relationship. What is relationship? Relationship that will represent the connection between the data objects. For example, the relationship between a shopkeeper and a toy is as shown below. Here, the toy and shopkeeper are two objects that share following relationship. Okay, what is the relationship between the toy and the shopkeeper? Shopkeeper orders toy. Shopkeeper shows toy. Shopkeeper sells toy. Shopkeeper stocks toy. That is the relationship between the two objects. Then next is the cardinality and modality. Cardinality, it is in a data modeling, it specifies how the number of occurrences of one object is related to the number of occurrences of another object. There are several kinds of cardinality: one to one, one to many, many to many. And next is a modality. Modality indicates whether or not a particular data object must participate in the relationship. Then next, we'll move towards our next topic, that is analysis modeling. Then what are the elements of analysis modeling? We'll study in detail. The analysis modeling, it is divided into 4 coordinates. Scenario based elements for the analysis modeling. Scenario based elements are there. Use cases, activity diagram, swim lane diagram. These are the scenario based elements. Flow oriented elements are the data flow diagram and control flow diagram. State diagram, sequence diagram, that are the behavioral elements of the analysis model. Then class-based elements are class diagram, analysis, packages, CRC models, collaboration diagram, that are the class-based elements. We have started analysis model, and we have seen it is analysis model is divided into 4 kind, or analysis model have 4 elements. Okay, scenario based element, flow oriented elements, behavioral elements, and class based element. First, scenario based models or scenario based elements are use case diagram, activity diagram, and swim lane diagram. See, what is the use case diagram? It is used to model the system from the user point of view. Use cases provide clear description of how system and end user interact with each other. That will show the relationship between the user and the different use cases, actions in which user is involved. These are the components of use case diagram. This is the actor. We will do some activity. Use cases, that will be the actions. Then association, that will be the relationship between the actor and use cases. The next, dependency, include, and realization. These are some more relationship in use case diagram. This is the diagram of library management system use case diagram. Okay, in this you can see this is the librarian and this is the member or student. Librarian activities and member activities are given in the use cases. It will check availability of book. It will verify member, and then he will member will issue book. Then librarian will calculate fine, and then member will return the book. These are some activities performed by the particular actors. The next is activity diagram. It will represent the flow chart between the flow from one activity to another activity. That is your activity diagram. Activity will be represented in this symbol. Then action will be represented like this symbol. Activity final mode is represented by this symbol. Decision mode, this is by the diamond, and then fog node, it will be used by this particular symbol. Then we will see how it will use. There are some join components of activity diagram. This is a join node. It will join particular things. Then this will be your initial node. If you want to give some note, then you have to write this particular shape. Then object flow, if a particular object is flowing from one activity to another, then you have to use this arrow. Then object node, it will be represented by the rectangle. This is the activity diagram to issue book. Okay, in this first, this is the start, then check availability of books, and then there are two conditions. If the book is available or it is not available. If book is not available, then it will display the message book not available. Else it will display, it will check for validate member. If the member is valid, then this loop will follow, and if the member is not valid, then it will display message not a valid member. Then next, if the member is valid, then check the number of books. Okay, and if the maximum quota exceed, then it will show message no more books can be issued, or it will show create transaction. Then it will take detail from user, update the book status, and then update number of books issued to the member. This is the example of your activity diagram. The next topic is swim lane. Swim lane, it is a type of flow chart. Okay, like flow chart, it visualizes process from start to finish. But it also divides these steps into categories to help differentiate which department or employee are responsible for each set of actions. Swim lane diagram make responsibilities more clear than regular flow chart. Then swimlane, in swimlane diagram, join node is used by this particular symbol. Then swim lanes are used by this particular symbol. The next swim lanes here. This is a member. Then this is a librarian, and this is your bookstore. Then what member will do? He will book a request, and these are the activities of member. You have to write in this part. The activities of librarian you have to write in this part, and then activities, or you can say the work done by the bookstore, you have to write here. Then next is a flow-oriented modeling. These are called as the structural analysis and design. Flow-oriented model represent information flow and transformations that are applied as data moves from input to output. There are some elements of flow-oriented modeling, that is a data flow diagram. Data flow diagram, it is the example of the flow-oriented modeling. Data flow diagram, it will represent an input of data to process or the output data from process. Data flow diagram, it is also known as the data flow graph or the bubble chart. It also used to represent the creation, reading, deletion or updation of data in particular database. Data flow diagram, it may be used to represent a system or software at any level of abstraction. You can see what are the components of data flow diagram in next video. Thank you for watching this video.